Hello, welcome to video 4a. This is Mr. Miller, and in this video we're going to do some examples of the chain rule. So this is an introduction to the chain rule. We're going to do a variety of functions, so hopefully all these examples are a little bit different and useful to you. Here we go. The first one we're going to consider is y equals sine of 4x squared. So the chain rule is for a composition of functions. We have the function 4x squared being substituted into the sine of x function. So when we do the chain rule, f represents the outer function. This is the outer function. So f is sine of x, and g of x represents the inner function, 4x squared. So like I said, we're kind of breaking this up into two functions. If we substitute 4x squared into sine of x, we have what we started with, okay? So if we use these two functions, this is equal to f of g of x, like down here. So that's what the chain rule is for. Okay, now we're going to compute the parts we need to write what the derivative is equal to according to the rule. So we're going to need f prime. The derivative of sine of x is cosine of x. And the derivative of 4x squared is 8x. Okay, so now we're going to write what y prime is. Okay, according to the chain rule, it's f prime evaluated at g of x. So f prime is cosine, but we're evaluating it at g of x, which is 4x squared. Then the chain rule says we got to multiply that times g prime of x. So times 8x. And then we simplify. There's not a whole lot we can do here. We can write the 8x first. So we get y prime is equal to 8x cosine of 4x squared. Okay, so this takes a little getting used to. So again, we use the chain rule. It's a composition of functions. We have to identify what the outer function and the inner function is. And then we kind of substitute into the formula here. All right, a couple more examples. This one's a little bit different. So the inner function is usually a little easier to find. It's inside the parentheses usually. So this is actually the inner function. That's g, 3x plus 16. And what are we doing to all that? We're raising it to the 5th power. So f of x must be x to the 5th. And sure enough, if we put 3x plus 16 into f for x, we would have that. Okay, so f prime would be 5x to the 4th, and g prime of x would be 3. So now the table just helps us kind of organize everything. Now we write the rule for the derivative. Y prime is f prime evaluated at g of x. So we put g of x, this, into, for x, into f prime. So it would be 5, instead of x, we're going to put 3x plus 16 to the 4th. Now we got to multiply by g prime of x times this guy, times 3. Okay, well we can do the 5 times 3 part, that's 15. So it would be 15 times 3x plus 16, all to the 4th power. Okay. Third example, this one has a square root function. So again, the inner function is x squared plus 9. And the outer function is the square root function. So we're substituting x squared plus 9 into x to get this. All right, f prime. Well, I'm going to work that out over here. Square root of x is equal to x to the 1/2. So that's f. So f prime would be 1/2 x to the minus 1/2, if I take the derivative. And another way of rewriting that is 1 over 2 x to the positive 1/2, which is 1 over 2 square root of x. So this derivative kind of comes up a lot. It's good to kind of know it. Square root of x, its derivative is 1 over 2 square root of x. So that's f prime. Okay, g prime is easy. That's 2x. Here we go. Apply the chain rule. We got to put g of x into f prime. So the derivative of y would be 1 over 2 square root of x squared plus 9. See, I substitute that in for x. Times g prime times 2x. Well, this would equal 2x over 2 times the square root of x squared plus 9. We can cancel the 2's. So we just get x over square root of x squared plus 9. Wow, okay, that's not so bad. We can do this. We're halfway finished. All right, next one is tangent to the third power. So let me rewrite this so it's obvious which one's the inner and which one's the outer. So recall when the exponent's like that, this means tangent of x to the third. So tangent of x is the inner function, x cubed is the outer function. So that would be f prime, and the derivative of tangent is secant squared. Right, that's a 2. Okay, so here we go. We got to substitute g into f prime. So this would be 3 times tangent x squared times g prime, secant squared. And we could write this as 3. We can put the exponent on the tangent function like this. That means the same thing. Times secant squared x. And that's a times. Okay, or just 3 tangent squared x secant squared x. There we go. Alright, no problem once you get the hang of this. Alright, eventually we won't need the table for this. We'll do it without the table, kind of see how it works, but it's great to help us out now. Alright, let's look at this one. Well, this must be the inside function. And the outside function is 1 over x to the third. We can think of it that way. So we're substituting 2x plus 7 into here to get that. Alright, now f prime. Time to go on the side again. If f equals 1 over x cubed, that is the same as x to the minus 3, then f prime equals minus 3x to the minus 4, which is minus 3 over x to the fourth. So sometimes we got to work out part of the problem on the side. So this is minus 3 over x to the fourth. Alright, g prime, derivative of that is 2. Alright, here it goes. G of x goes into f prime. 2x plus 7 to the fourth times g prime, which is 2. We can multiply the negative 3 and the 2, and we get negative 6 over 2x plus 7 to the fourth. Alright, now we have just one example left, and this is the cube root function. Okay, we can do this. It's going to look like the square root function. So the inside function is sine of x, and the outer function is the cube root of x. F prime, well, here we go. We got to remember that the cube root of x is equal to x to the 1/3 power. So if I take a derivative, it'd be 1/3 x to the minus 2/3, which is 1 over 3x to the 2/3. And then I'll use sometimes we leave it like that. That'd be okay, but I'll tell you what, let's use radical. I'm sorry. So I'm making up my mind here. We can either just leave it as x to the 2/3 or change it to a radical. Let's change it to a radical. So this would be 3 times the cube root of x squared. Because the cube root of x squared is the same as the 2/3 power. So, wow, that was tough. That was actually the hardest part here. 3 times the cube root of x squared. Then, g prime would be cosine x. And here we go. So, y prime equals, we got to put g into f prime. So this would be 1 over 3 the cube root of x squared would be, we're putting sine in, so sine squared x times cosine x. Wow. And that would just equal cosine x over 3 times the cube root of sine squared x. Alright, I had to go out with a bang, so we had to save the tough one for last, but it's okay. We would have been okay leaving it as x to the 2/3 here, and maybe that would have made it a little bit simpler, so that would have been fine. Alright, it's time for the journal assignment. So we have 3 problems for you. You need to use the chain rule for each of these. So please copy the original function down, draw a little table for f, g, f prime, and g prime, and use the chain rule to find the derivatives of these functions. Alright, take care.